In Chapter 10, we're going to start learning what radians are. So to start off, we have the definition of what 1 radian is. A radian is a unit used for angle measure, just like we've been using degrees. We say 30 degrees, 360 degrees, and now we're going to start using radians. So the definition of 1 radian, 1 radian, is the measure of the central angle that intercepts or cuts off an arc on the circle that is equal in length to the radius. So up here in this picture, we have a radius of our circle in red. If we could take that radius length and bend it along the circle, bend it along the same radius length, then this angle that is cut off right here, this is the central angle, would be 1 radian in measure. Let's take a look at Wikipedia. They have a pretty good visual of this. Right here, there's the circle with the red radius, R. They take that radius and bend it along the circle and then show you that 1 radian angle. Now they're going to expand it to 2, there you go, and 3, and then pi radians. A little more than 3 gets us to 180. Kind of cool. All the way around will be 2 pi. So this little applet here is pretty cool. Let's do it again. There's the radius. Draws the circle. Bend it along the arc of the circle. That's 1 radian. Then they go to 2 and 3, and you can see a little bit more would get you to 180 degrees. That's pi. And all the way around 2 pi. So you can go back to Wikipedia on your own as well and look that up. Pretty cool. So the measure of an angle can be expressed in degrees or in radians. And what we're going to learn to do today is to convert between the two. So you saw in the graphic on Wikipedia that what we would refer to as 180 degrees was equivalent to pi radians. So we're going to use that to convert. Pi radians, little r there, is the same as 180 degrees. That's like saying 12 inches equals 1 foot. So think of it that way if you'd like. We're just converting between different units. So if pi radians equals 180 degrees, then anytime we have pi in one of our problems to convert, we can actually just substitute in 180 degrees. And make sure you're putting the degree symbol now. So pi divided by 2 radians would equal 90 degrees. Let's try a couple more like that. Pi divided by 3. Well, if pi radians is the same as 180 degrees, substitute that in, divided by 3, and we have 60 degrees. Right? Let's try one more like that, where we're simply substituting in 180 for pi. Here we have 3 times 180 divided by degrees is what you should have. Okay. Now there is another method that I do want to discuss because we'll need something similar to go the other way. If we know that we are converting 2 degrees, then we can also multiply our given radians by 180 degrees over pi radians. Because if I'm taking anything with radians, my given is radians, and I'm multiplying by degrees over radians, that means I'm left with degrees. So I'm going to try that strategy for these next few. 180 over pi. You can see in this case the pi value cancels. I can even reduce 3 into 180 and get my answer, negative 120 degrees. Let's try that again. Converting 2 degrees, I want my degrees on top, over pi radians. Cancel the pi. 6 goes into 180 30 times, and I have 150 degrees. Right? 11 pi over 6. Keep trying it this way. The pi values cancel. 6 goes into 180 30 times, and I believe we have 330 degrees there. Okay. Now, because each of those contained pi, I could have also just substituted in that 180. 5 times 180 over 6, and of course the math would be very similar. 6 goes into 180 30 times. So when you have pi in the question that you're converting, you can use the substitution strategy. But look at these last 2 questions. Here I just have 3.89 radians and negative 1.02 radians. So here I don't have that pi that I can substitute in for. So I have to multiply it by 180 divided by pi. And then my radians, of course, are canceling. Just the radian length, so that I'm left with degrees, like I showed you here. So now you literally have to type 3.89 into your calculator times 180 divided by, and pi is right above that caret underneath the clear button. So second pi, so 3.89 times 180 divided by pi gives us approximately 222.9 degrees. Let's try the next one. Use your calculator. Negative 1.02 times 180 divided by pi. And use the pi value on the calculator, not 3.14 or anything like that. This is approximately negative 58.4 degrees. All right, so 2 to try on your own, but I won't give you the answers for right now. Let's try 3 pi over 5. You convert that, and 5.2 radians. So convert both of these to degrees. And we'll check those tomorrow. All right. So now that top section was converting radians to degrees. Now we want to convert degrees to radians. So here we are going to multiply by, if we're going to radians, we want the radians on the top, pi radians divided by 180 degrees. So again, if we're given degrees, and we multiply it by radians over degrees, the units, degrees, would reduce out and you're left with radians. So we want the radians on the top, pi radians. So 270 times pi divided by 360. Notice I sort of write it so that I can see I'm going to be reducing 270 and 360. They're both divisible by 10, and then they are also both divisible by 9, excuse me. If you want, of course, many of you will use your calculators, but you really don't need to. This is going to be 9 into 27 is 3, 9 into 36 is 4, and you end up with 3 pi over 4. That's radians, and we leave it in terms of pi. Hmm. 225 is next. Let's see if I can push this up a little. There we go. 225 degrees times pi divided by 360. Want to see if the fraction can be reduced. Use your calculator if it's a little quicker. I'd rather you do it by hand. The answer will be left in terms of pi. And let's see, 45 goes into both of these. 9 goes into them, 5 goes into them. So if you're reducing, you should get all the way down to 5 pi over 8. Negative 300 degrees times pi over 180 degrees. You can see your degrees are canceling. I can divide by 10 in my head, and then you have a 30 and you have an 18. 6 goes into both of those. You should have negative 5 pi over 3. Okay. 150 degrees times pi divided by 180. Make sure you're going the right way, getting those degrees to cancel. Divide by 10, and then divide by 3. 5 pi over 6. You can put that little r there to signify that it's radians. Might help you keep things straight. Okay, good. Try a couple on your own. I'm going to have 270 degrees for you to convert and negative 240. Take a moment, pause, do those two on your own. Leave your answer in terms of pi, and we'll see how you do tomorrow. So on the next page, a little practice with converting the angle to degrees first, and then we're going to draw that angle in standard position, and then give the reference angle. So we're practicing some of the concepts from the last chapter in this chapter. 7 pi over 3. First, let's convert. I'm going to do 7 times 180 divided by 3. 3 goes into 180 60 times. And so this is a 420 degree angle. Now, 420 degrees in standard position swings around 360, and then we are left with 60 more. So we're going to go a little bit further. This center line is for 45. So our angle is something like that. We found the angle in degrees. We drew it in standard position. Now the reference angle, 60 degrees, in radians would be pi divided by 3. Pi over 3 equals 60 degrees. Another way to start thinking about this, you saw earlier, we know that pi radians equals 180 degrees, and you saw on the Wikipedia applet that 2 pi is 360 degrees. So all the way around the circle is 360 degrees. So an angle in standard position, swinging all the way around, is also 2 pi radians. So swinging all the way around is 2 pi radians. In a case like 7 pi over 3, 2 pi radians would be the same as 6 pi over 3. These are equivalent. That's a full circle. So if I know I'm going 7 pi over 3, that means I'm going 1 pi over 3 past a full circle. And 1 pi over 3 is what turns out to be your reference angle. So keep in mind, we might go 1 full circle, 360, 2 pi, start putting all of this together. Okay. Next question. Find the angle in degrees. So we're going to substitute in for pi 180. It's negative this time. And negative 5 times 180, or you could divide 4 into 180 as 45. This comes out to be negative 225 degrees. So we know how to draw negative 225 perfectly through the center. The reference angle, remember the reference angle is an angle in the triangle made with the x-axis. So our reference angle, I know in degrees, is 45 degrees. And let's see if we can figure out, if we converted that to radians, we would have pi divided by 4. Okay, pi divided by 4. Anything with a 4 in the denominator is going to be one of the 45 degrees in one of the quadrants. Keep your eye out for those. 5 pi over 6. I'll do this one by multiplying by degrees over pi radians, just to do a little different. 6 goes in 180 30 times. This should be a 150 degree angle. Draw that in standard position. 150. There's 150. Your reference angle would be here in the triangle. To the x-axis. In radians, that is pi divided by 6. Pi is 180 degrees, and divided by 6 gives you 30. in here. Hope I'm still recording. All right. Well, whoops. Didn't mean to hit that. I don't know if I'm still recording. Let's see. I think I am. Make sure so that I'm not just doing this. Possibly not. Well, I'll go to the end and we'll see if it's recorded or not. The last thing we need to do is the arc length. So we have to be able to figure out how much of an arc of a circle we are using with a central angle in radians. So arc length is a new variable called S, and it's based on the radius of the circle, and it's based on the angle that cuts off that arc. The formula is S equals theta times R, and you want to make sure that you have theta in radians. So it's given to you in degrees, you need to switch that. So these are pretty simple. S equals 6 and R equals 2, find theta. Use our formula. They're saying S is 6, find theta if R is 2, and so nice and easy, theta is 3 radians. If theta is 2.5 and S is 50, 50 equals 2.5 times R, divide by 2.5, and we get that R is 20. So the radius of the circle would be 20. If an arc length of 50 is cut off, S equals theta R. You can see again, that's what I'm doing. Find S if theta is pi over 4 and R is 0.8. So we'll find an approximation for this. Pi times 8 divided by 4, or pi times 2. And that's approximately, rounding it, 6.28. All right. Last two questions are word problems. A wheel whose radius measures 16 inches is rotated if a point on the circumference of the wheel moves through an arc of 12 feet. So we've got some point that's going to move 12 feet. Now that's probably going several times around, but that's clearly S. So let's see, this was inches. S is 12 feet. So I want to get those the same first of all. This would be 144 inches. What is the measure in radians of the angle through which a spoke of the wheel travels? So I know I'm using S equals theta R because we're on the arc of that wheel. For 144 inches, we're looking for theta. So all we need to do is divide by 16 and find our angle in radians. And that's 9. 9 radians. So clearly more than a full revolution. So a full revolution would be 2 pi, right? 360 degrees. So 2 pi, which is 2 times pi, is approximately 6.28. So if I'm going 9 radians, that's more than once around. And the last question. Through how many radians does the minute hand of a clock turn in 45 minutes? So first we're really just thinking about a clock, and if we go 45 minutes, then we've gone that many degrees, or I suppose since that's the way the clock hands go, how many degrees is 45 minutes? So Most of us would think 270 degrees, and then maybe let's convert it to radians. So we're going to multiply 270 degrees times pi divided by 180. We'll leave it in terms of pi. 9 goes into both of those. 3 times, then 2 times 3 pi over 2 radians. That's the value in radians of 270 degrees. So now it says if the minute hand is 5 centimeters long, that's going to be our radius. How far does its tip travel in 45 minutes? We already know our angle is 3 pi over 2 radians, and they're actually looking for, along the outer edge of the circle, how far would that travel with a radius of 5? That's S. Along the edge, the arc length equals, S equals theta r. So, 15 pi divided by 2, or if you prefer, 7.5 pi. We leave your answer in terms of pi. If you multiplied it by pi, then you'd probably get something in the 20s or the close to 30. So that's it.